Hello. In this video, we are going to deal about the sixth experiment of Introduction to Data Science Lab, that is simple linear regression. The course outcome of this topic is to discuss the principal operation of the supervised learning classifier. The regression analysis is one of the supervised learning classifier, and also to analyze the performance of the classification, prediction, and the recommendation. Here we are considering the classification of the prediction technique. Simple linear regression is one of the supervised learning technique. The machine learning algorithms are classified into supervised learning and unsupervised learning. Again, the supervised learning is classified into classification and regression, whereas the unsupervised learning is classified into clustering and the association. The supervised learning, one of the technique is the regression. Regression is mainly used for prediction. The main purpose of the regression is the prediction. The regression analysis means we can analyze the role of the dependent variables in respect to the independent variables. So here in the regression analysis, consider if you want to predict the price for the house, it depends upon many variables. So we can develop a regression model such that the house price can be predicted from the existing variables called date, square feet of living, rooms, and floors. All these are the significant factors for identifying the house price. So here, this output variable or the target variable is the house price prediction, and this is what called as the dependent variable because it depends upon the four different factors. So otherwise the four different features. So here the left hand side, these variables are called as the independent variables. All these independent variables plays a significant role for the house prediction. So house prediction is the dependent variable or the target variable or the predictor variable which depends upon various input variables. All these inputs are given to the regression model, and regression model based on the input, it will predict the output. So this is the supervised classification. That means it needs training as well as the testing. First, the training is done with the known inputs as well as the output, and then that values are tested whether the prediction is correct or not. If the prediction error is less, then it will be a good prediction model. The prediction, we need some observations. The observations means the data as well as the features. From the data set, the significant features are identified. For that, we need the correlation. If there exists a correlation between the features, then we need to take the variables. Otherwise, we should not take the attributes. For example, consider the heart disease. When we are predicting the heart disease in the data set, it contains the number, age, color, as well as the heart disease. Means age plays a role to predict the heart disease, whereas color and the number won't influence the heart disease. So we should not take that. So we should analyze the correlation between the variables. If there exists a correlation between the variables, then that variable is only selected for the prediction. We should know how and what extent these features affects the prediction. For example, consider the weather prediction. In the weather prediction, humidity as well as the room temperature, everything is required. But when you consider the color of the wall, it won't affect the weather. So we can't take such kind of attributes. Some examples for the prediction are rain using the temperature and other factors, determining marketing trends, prediction of road accidents due to rash driving. These are some of the prediction examples. The regression analysis is mainly used for prediction, and it's divided into many categories: linear regression, polynomial regression, support vector regression, decision tree regression, lasso regression, logistic regression. So many regression techniques are available. We are considering only the linear regression techniques. That is, the variable is linearly dependent to another variable. We go for this one. So the linear regression is again classified into simple linear regression, multiple linear regression, polynomial regression, as well as the logistic regression. In our example, we are considering only the simple linear regression. Linear regression means consider y is the dependent variable and it depends upon the input variable x1, x2, etc., xn. Linear regression is a statistical regression method which is used for predictive analysis. It's used for solving the regression problems in the machine learning algorithms. In the linear regression, if you are considering only one variable, that is called as the simple linear regression. That is, the output depends upon only one input variable or only one decision variable. That is called as the linear regression. In this example, if y depends upon only x1, the equation becomes y equal to beta naught plus beta 1 x. So here this is called as the simple regression. Y equal to beta naught plus beta 1 into x. This is similar to our line. It's a equation of line. Y equal to mx plus c, where m is the slope and x is the variable. Similarly, here this beta naught is called as the y-intercept and beta 1 is called as the regression coefficient. Initially, from the given data, that regression coefficients as well as the y-intercepts are identified. In the Python library, there exists a library function for predicting the developing the regression model. So with the known example, with the known input and output, that line of regression is plotted. And these are all the data points. Initially, the regression model is developed and there exists a line of regression. Here, when you plot the independent and the dependent variables, this scatter points or the data points, whereas line of regression is the model fitted by the given data points. So here, after that, all the data points won't coincide with this line of regression. Then it is 100% accurate one. There is no error in that, but it is not possible in all the data sets. That difference between this line of regression, the difference between this line as well as this, the point is calculated as the error. This is the error between the error in the data point. The error is calculated, and if the error is less, then it will be a good model. When you fit the model, if the error is less, then it will be a good model. If there exist outliers means the points, data points that is deviated from the existing data, then it also affects the line of regression. So before processing that, we should remove all the outliers as well as the null values to get the to improve the accuracy or to reduce the error in this linear regression model. So here the performance of the linear regression can be calculated by using mean absolute error, mean square error and the R square error. These all are the measure levels. These all are given by certain formulas. MA is like yi minus y bar. This is the absolute error between the line of regressions and the data points. Mean square error means it will be the square point. The small amount of error can be magnified by using this one. In both cases, we won't consider the positive and negative. Only the magnitude of the error is calculated. If the error is less, then it will be a good one. It can be implemented by using Python. We are using Data Lab for implementing this one. This is the Python code for implementing the simple linear regression. Initially, import the library functions, pandas as well as NumPy, and then we use the matplot library for visualization purpose, include that also. Then math function, here we are calculating the mean square error, mean absolute error. For calculating that functions, we include the math function also, and some matrices for identifying the performance of the system. First, read the value. Here I am using the employee data set. Read the data set. These are the attributes of the data set: first name, gender, salary, team, age, experience. From by analyzing this one, we can identify here first name, gender, team. It won't affect the salary as well as experience. Here this is the simple linear regression, so I can select only one input variable as well as the output variable. In our experiment, we are selecting the salary as well as the experience. So before that, I'll identify the correlation between the factors. When I consider the correlation between the factor, there exists a correlation between experience is the output variable. There exists a correlation between salary and the experience as well as age and the experience. Higher correlation is between the salary and the experience. So I am going to develop a regression model in between the salary and the experience. So for that, I already told you, for we should remove the outliers before performing the linear regression, because the outliers increase the error level. So here I drop all the null values. And after removing the null values, I have calculated the correlation by using the df.corr gives the correlation between all the variables. By identifying the correlation, there exists a correlation between high correlation between the experience and salary. So I consider only the experience and salary for developing the linear regression model. So data first extract the dependent variable and the independent variable. In my example, the independent variable is the input variable is the experience that is extracted, and the output variable is the salary that is also extracted. These two values are extracted by using the selecting column feature. It may be iLoc or loc, any feature. You extract these two columns first. Then this is the supervised learning technique. So we need the training as well as testing. Generally, we use 1:3 for training as well as the testing. That is, one part is for testing and 3 is for training. Otherwise, 70:30, 70 for training and 30 for testing. So I call the function train test split. I need to split the entire data set for training and the testing. So from this library, here we are using the sklearn library because sklearn is specifically for the machine learning algorithms. This regression is one of the machine learning algorithms. So I select this sklearn model. From that, the train test split is imported. Then that is carried out. Here I am split the data set into training and testing. After that, I use the linear regression model. So from the same library, I am importing the linear regression to fit the model. The linear regression, we use linear regression or fit to fit the model, fit the data into the model. Training set data are fit into the model and the model is developed. Then that model is tested with the X test values. So the X test values, and we will get the Y test values, that is the predicted values. We will get the predicted values. Y predicted values are also calculated and that is displayed here. And finally, the model is developed and the values are predicted. Then we want to visualize the values. We need the regression line as well as the error between the data points as well as the fitted regression line. As for that, we use the scatter plot. With the help of the line plot, we will plot the regression model, and the scatter plot, we will display all the data points. Here I am displaying all the data points as well as the regression line. This one is the line of regression and this is the data points. Here the salary versus experience having less significance. So the data points are scattered everywhere and not closer to the line, and the error is also high. So in this example, the mean square error and mean absolute error as well as the R square error values are high because this is not an appropriate data set for this regression analysis. If it is a good data set, the regression analysis, all the data points, these data points coincides nearer to this line, then it will be a good model. If it coincides with the line, this is the good model. Otherwise, the error level is, this is the error level between these, this is the error between this data point as well as this line. This is the error point between these two. Such manner, all the errors are calculated and the mean value is taken. That is the mean absolute error. So in this regression, if it is a good model, if it fits in a good manner, the absolute error as well as the mean square error must be less. So the question is, you should develop a regression model for the given data set and test the significance of the developed model. Thank you.